All right, this is our bedding plants installment for crops 2. This is a longer lesson. I am gonna apologize. It doesn't. It's hopefully it's not as bad as you think. There's ample time for you to pause any. Well, you really can pause anytime to take a break, right? Lucky you, because if you're in class, this is definitely a marathon one. Um, but let's dig right in because it's an important one. Uh, Bedding plants. What are they, right? So typically in our industry, it is grown for mass market. There's a few small garden centers that might grow their own, but generally speaking, they're contract grown for mass market, right? So we're talking lots of plants in a single space. Um, and generally, the rule of thumb is that bedding plants are sold in full color. Way back in the 50s, bedding plants were sold often with no flowers. You had to look at the care tag to see what was coming, which is unusual. But genetics and breeding and growing practices have brought us to full flower. Um, Essentially, not all species that are out there are amenable to mass production, and so that limits us to 70. But to be honest, like 70 species is a lot. I suspect most of us don't know 70 species that would fit in the garden off the top of our heads. Um, as far as in the past, it used to be small garden centers, ma and pa's, as they call them, and they would grow their own plants and market. Uh, that is pretty much gone the way of the dodo bird, as they say. It's extinct. And that's because they cannot compete with cost of production with large facilities. It's also not necessarily a bad thing because, to be honest, a lot of the ma and pa plants were just not up to snuff. They didn't have all the technical facilities to grow quality plants and consistent plants. So, and then on top of that, like, unfortunately, a lot of our shopping habits have changed such that, customers like to go to these stores we all recognize for their plants, right? Home Depot, Loblaws, Costco, maybe you've heard of Terra if you want an independent kind of example. But they're all big box stores, right? Chain stores. And they have expectations, right? So consumers want excellent garden performance. That's what they're looking for. And retailers want full color because they want to catch your eye. They want them to look good and have shelf appeal. They also want them to be able to last on their shelf for 2, 3 weeks and not, peter out and start going yellow and turning upside down. So, uh, is this compatible? Are all these things compatible? It's hard to say. There's compromises made. For example, shipping in full color and keeping the plants compact might mean using growth regulators, which might impact garden performance when the customer plants it. So, just as an example, they're not always 100% compatible. So the farmers have to make compromises. The other thing that chain stores require is very narrow shipping windows. When the stores open, they want it now, but they don't want it before that. And then as soon as it's gone, they want a replacement now. So there's shipping is intense. A lot of farms will double crop, which takes a lot of planning. So you start your plug production, plant it out, grow it on, ship it. But in the meantime, you started yet another set of plugs that you can immediately plant out into the spaces that you pulled for your early orders. And by double cropping, you can max out the amount of profits from your farm or keep your costs under control, right? Uh, 3 to 4 weeks shelf life built into the plant. That's tricky to do. 2 to 3 weeks is probably more realistic. And to be honest, if your product sits on the shelf for 4 weeks, odds are they're not going to order it again because it just didn't sell. They want stuff that flies out the door, that they can then flip and put fresh stuff on the bench and sell that. That's how they're making good money, right? Um, so who decides what to grow? This is a funny thing, right? You'd think that customers decide, but really it's not the case. Retailers, Home Depots, Canadian Tires, they have marketing programs and they pick themes. It's kind of cheesy. I've witnessed it, where they'll say, this year we want yellow and pink hanging basket plastic containers, and we want to have these kinds of Calibracoa that are going to match that, and that's our theme for this year. Um, it's really weird sometimes. They look at home decoration trends and things like that and try to make intelligent decisions. Sometimes they get it right, sometimes they get it wrong. I don't know if it's right. I think every color should be there and consumers should decide. But whatever, it's big business. The other thing is that the breeders will market things to the retailers, right? So they'll say, hey, we've got this new black petunia. You should try this. And then, of course, the grower's then told, hey, you have to grow black petunia. So growers are usually the least important in the decision-making process. We try hard to steer the buyers and the retailers so that we're not growing stuff that's impossible to grow, but at the end of the day, you're told what to grow. And those things can change constantly. So if you're lucky, you get a year in advance to trial it and perfect how to grow it, which is the ideal scenario because some crops have tricks up their sleeves that you don't know about. And if you go full bore with a large crop and suddenly have problems, that can be very costly, right? So we try to keep it a year ahead, but that doesn't always work out. What are challenges? Okay, so sale dates, like I mentioned earlier, that can be real challenging. You're dealing with Mother Nature and changing seasons. Springs can be cloudy and wet or dry and sunny, and all those things are external influences on your crops that you have to manage, and that impacts your ship date. So timing is absolutely critical. Their other thing is that you may have different size containers. We used to have simple 4-inch, 6-inch, and 1204 trays and cell packs, right? That used to be what it is. Now it's all over the map. Every retailer wants to have customized pots and sizes and shapes. Sometimes they're tall, sometimes they're narrow. It's all over the map, and growers have to try to accommodate that. And so in this farm here, they have flood floors, right, which are very adaptable to all different kinds of pot dimensions. Where if you had benches or troughs, you're limited to the dimensions of the bench and the shuttle trays and all that. So there's a bunch of factors that can be challenging in planning out your space. The other thing that I've seen is branded containers, right? So this is a Proven Winners container. This is your classic Wave Petunia container. If you're a farm and you're supplying different customers, it's absolutely essential that the right containers go on the right carts, because if you ship a Home Depot pot to a Loblaws, you are in some serious trouble. So organizing all that and quality control as to what goes on the trucks is absolutely important. Pay by scan. This is another one that's a real pain in the butt. Walmart introduced this, and a lot of stores do this. I think I mentioned it briefly in the fall. The idea that whether it's a barcode or a QR code, when you scan it at the checkout, the farmer only gets paid at that point. Otherwise, the farmer still owns the product, and it could be drying out in a cart in the back corner of the garden center, and the farmer has no clue. That's a stressful situation. Anyway, so moving on to growing bedding plants. There's obviously different stages. You have your seedling stage, or your rooting of your cuttings. Then there's a transplant. Then they have to grow through juvenile and then eventually set flower. And then we have to harden them off so they're ready for the garden center. And then lastly, we ship. So I'm going to walk you through these stages in the bedding plant process. Starting with propagation from seed, okay? So whenever it's possible, seeds are the cheapest, easiest option. Whenever possible, it's really important. So typically, we like to grow hybrids. So a lot of the bedding plants grown from seed are hybrids, which means you get big flowers and big plants, and they grow vigorously. Seeds are definitely cheaper than cuttings, which is a big bonus. They can easily be deposited into the soil with machines, which cuts down on labor. And they usually are really uniform because they germinate at the same time, they grow at the same rate, everything pops up at exactly the same time. Whereas with cuttings, that can be a little more difficult. Um, the juvenile phase is a little bit of a challenge, but it does give you a phase, right? Where if you grow from cuttings, quite often they skip the juvenile phase. They go directly from rooting to flowering because the cutting came from a mature plant, as opposed to a seed, which has to go through germination, juvenile, and then transition into reproductive growth. So you have that extra step with seedlings for control if you need to slow or speed up your crop. The other thing is that there's less risk of introducing disease. When ovaries in a flower form their seeds, the seeds are sealed off from the external environment and even viruses, which means that the risk of disease transmission is really low with seeds, whereas with cuttings, you're introducing whatever's in the vasculature. So there's viruses, there's endemic bacteria, there could be spores in the tissue, on the tissue. So definitely seeds are the way to go. And a lot of seeds are pelletized. This is these are actually Streptocarpella seeds, which are very, very small. You're looking at about a thumbprint of seeds there. Right, so that put your thumb over this whole area, and that's how small the seeds are. Those are very difficult to work with. So what the factories that produce these do is they roll the seeds in clay, and they become a little clay ball, and in the center of the clay ball is your seed. And now that they're a little bigger, it's easier for machines to pick them up and deposit them when they're seeding out the seeds. There are some exceptions, like marigold seeds up here in the top corner, which are elongated, just like Gerbera seeds. They're a little tricky to work with. And so certain seeding machines will not work as well with these, and they require a little more labor to fix. But fortunately, a fair number of seeds are round and they work well with pellets. All right, so plug production. Why do we grow plugs? Uh, Typically what a plug is a compact plant, right, grown in a very small volume of soil. And the idea is that you can have a lot of plants in a very small area. Look at these trays. These are 512 trays. That's about the size of a tray. And if you look in this room, there's probably millions of plugs, millions, and that's in one bay. So you can store a huge amount of plants. Remember early on I said you can double crop? So let's say you're shipping plants out of this bay and you have plugs ready to go to fill in the spot that you just emptied. You can have quite a few plants sitting here and waiting to fill in to expand your production as you sell product out. So that's where double cropping plays a big role. And plugs are meant to be, when they're fully grown, they're just kind of bursting at the seams, ready to go to become a bedding plant. So let's talk about that. Commercial plug production. Love booms, big fan of them. Very, very useful in plug production because you get the most uniform irrigation. All right, so plugs, what are they? Miniature plants with fully developed leaves and flowers often, sometimes just buds. So fully developed. Leaf and stem expansion is inhibited, right? So the idea is that you've controlled the growth, you've kept it compact, you've held it back, so that when it's transplanted, it just takes off. That expansion versus growth is critical because in order for growth to occur, the cells have to reproduce DNA and the cells have to divide and then they have to expand. That takes time. And if you're trying to move things quickly, time is not helpful. You want to have expansion where all you have to do is add water and a little bit of feed and the cells quickly elongate and the plant gets big. So by monitoring things like water and nutrients and even growth regulators, we can hold those plugs at a state and then release them when we're ready. So as I said, critical for double cropping. What are advantages of plugs, right? So that it's easy to transplant them with a machine. I've got some video links in these slides you can look at on your PowerPoint and on the web page for this week's class. I'm not going to put them in the video because it's already going to be a big video, so I want to keep it short. So it allows for double cropping and also uniformity. That's really critical, right? Especially for planning out what you have to ship at any given time. You don't usually have the luxury of planning the day off. You need to know a week or two in advance. And so when everything's uniform, it's easier to know exactly what you have to ship. Disadvantages. You need a lot of money to have the equipment to do it well. And you need good growers and crop control methods for this to work. That's a, a tray of petunia seedlings, nice and uniform. Just, I don't know why I have that there, just so you can see it, because it looks cool. So uniformity is key. You'll hear that word frequently, uniformity, uniformity. Very important. If you're transplanting with a robot, so mechanized transplanting, if 50% of these plugs didn't germinate, and the robot doesn't know which is a plug and which is not. It just goes to every single cell, picks up what's there, and puts it in a pot. That means that all the pots that didn't get a plug because it was empty in this tray has to be replaced with a plug manually by a person. And I remember years ago touring Jeffrey's greenhouse where they have a robot doing transplanting. They have a conveyor after the robot where they had 3 staff fixing pots that were missing plugs because of the odd seedling that didn't germinate. And the grower said that if they went from 95 down to 90% germination, they had to go from 2 to 3 people sitting outside the robot machine fixing pots to 25 people to keep up with the throughput. That's massive. And you can imagine the logistical headache and the owner being very unhappy with the grower if that's the situation in order to keep production up to speed. So it is a very important thing to have uniform germination. The other thing is I talked about reducing leaf and stem expansion, right? Using water and nutrition. We have to be able to do that without causing permanent damage. Now, some plants, if you let dry down too low to like a stage 0 or 1, it's very difficult for them to reverse that. You know, they may not grow out of it. They may be almost permanently dormant or take weeks to continue growing again, or maybe never grow and just die. So it's very important to monitor that control. And of course, every species has its own requirements, which complicates things even further. Although fortunately, for the most part, these methods work fairly universally. But a lot of farms have a book where the growers keep notes so that they can make notes on what worked well in one year and what didn't, and then move that knowledge forward to the next year so they don't make the same mistake again, right? So you can consult your notes saying, hey, last year when we grew petunias, we ran into this problem and we figured out that, hey, you know what? We shouldn't let them dry down so much at stage 2 or whatever. So those notes are really important to go back to as a grower. So what are the stage of plug production? We got 5 stages if you include stage 0. Don't know why it's 0. That's just how I started. That's just flat filling the tray with soil and sowing your seeds, and then whether you cover or not depends on if the seed needs light or not, right? Germination happens next, right? Until the root emerges or the root radicle. That means germination has happened. Then we move on to the cotyledon, followed by the first true leaf, and then of course the true leaves, and then lastly the holding stage or bud formation. So let's start with 0. Pretty straightforward. You're going to pre-moisten the media. You're going to dribble it out over the trays, flatten it. It is really important when trays are filled that the soil is not pressed into these trays. I know that at the college, a lot of you fill trays by dumping soil on the tray and swiping it off with your hand, and then maybe wiping it left to right. Oftentimes, that method actually compresses soil into the tray, if nothing else, differently across the entire tray. It's not uniformly filled. Where you put your hand down and press some soil in, those trays, those cells will get more soil and less air pockets. And in the corners where it loosely filled as you scattered it across, it gets less soil and more air pockets. You've already made your first mistake in terms of uniform growth and germination. So mechanization is the key for success in uniform germination. A really important lesson there, okay? We do not have a machine at the college. I don't know why. I've asked for one for a number of years, but I guess it's nice to have jobs for you guys, so I shouldn't push too hard. Next thing is dibbling the cells. Dibbling the cells is done with these sorts of machines. It's like a wheel that rolls as the tray slides underneath, and these fingers punch dimples into the soil, and that's where the seed drops. Next would be seeding. There's different types of seeders. This is called a needle seeder, where each of these blue tips is basically like a hospital needle, kind of. And in this tray is a bunch of seeds that are shaking around. And this arm lowers down into here, and the needles have suction in this arm. There's air being sucked out, and air is rushing into the needles. And so when the needles touch the seeds, they suck up a seed, right? Then the arm reverses and travels back behind and drops down over the soil, and the vacuum is interrupted, and then all that whole row of seeds falls into the soil. And so as the tray goes underneath, each row in the tray is individually filled. Now that's a slower process because it does one row of cells for each movement of this row of needles. So if you have a 288 cell thing, there's what, 24 rows of cells. It's going to take, this needle arm has to go back and forth 24 times to fill that whole tray. So it's quite a bit slower in terms of throughput. Now, a drum seeder, which is pretty cool, and I'm going to encourage you to go and check out this YouTube video so you don't fill out this video. But essentially what it is that unlike the needle seeder, what happens is there's a drum here. And this drum is a cylinder that rotates. So think of a tube, right? And inside, there's a vacuum pulling air out of the inside of this tube, okay? So on the tube, there's hundreds of holes. So the holes are sucking air in, and this tube is then rotating, okay? And on the back here is a tray full of seeds. And as the tube rotates by, these vacuum holes go by the seeds and pick up a seed. So every single hole has a seed sucked against its hole. As the tube rotates down below here, it gets to the point where the tray is. So the tray is sliding through, right? It's got all its cells. And as it slides through, the wheel rotates at the same speed as the tray. They match each other as it's shooting underneath. And each row of seeds on the drum, there's many, many rows, match each row of the tray. So the tray rolls through at exactly the same speed as the drum rotates. And just as the seeds come down to the bottom here, inside here is a wiper which breaks the vacuum, and it drops each row of seeds. So instead of having needles going back and forth and back and forth and back and forth, the tray rolls through like a printing press kind of. And as that drum rotates along with the tray, it's dropping seeds instantly into every cell as it rolls through. So these machines will just churn out seeded trays by the hour. I mean, thousands by the hour. They just fly out. Then there's always someone standing beside it monitoring and with a big red button to stop it in case they run out of seed or there's a piece of debris that's blocked a hole in the drum, and they will fix it. Now, there typically is still, at the end, you'll see there's a conveyor here, there is still a couple of staff people that will manually dropping seeds in the cells that they can to try to make sure that all the cells have a seed, because we want to get as close to 100% for each tray as possible. Remember, that's what we need for the robot for transplanting. So we move on to germination. This is an interesting stage, maybe new to some of you. This is a homemade chamber. I've got a picture kind of the next slide of a commercial chamber, but what am I talking about? I'm talking about a humidity chamber. So when we're germinating seeds, we do it at 100% humidity. Now, I don't know if you know why. Now, the last slide we were seeding trays, which would have gone through a little bit of a gentle irrigation tunnel to water those trays. And then those trays would be loaded into a germination chamber. Now, if the germination chamber is at 100% humidity, what's going to happen to those moistened trays? Are they going to dry out? No, because they're in a room that has 100% humidity. So how can they dry? The air is already saturated. And the reason it's saturated is because you don't want to go in with a watering wand and start watering your trays. And as the water hits the tray, it's going to water unevenly. It's going to dislodge seeds. It's going to maybe knock soil over seeds. Some seeds will be deeper than others. You're going to get uneven germination. And remember, this is all about uniformity. So a humidity chamber or a germination chamber is how it's done. It keeps everything even. You don't get drying out on the edges, nothing. It is 100% the first critical step, one of the first, well, they're all, but this is another critical step in obtaining uniformity. Now, sometimes in these chambers, they have photo lights. You know, some seeds need a red light in order to germinate, or far red light. Some don't. So you have to pay attention to what you're planting. And those germination rooms may have a red light in them or not. You don't need much. You just need a little bit. It's also warm, right? So it's humid and warm. Think jungle, and that's how you get germination to happen. And of course, you have a computer-controlled environment that's kept at 100% humidity without having to get so much water in there that the leaves are getting, you know, or that things are getting too wet. So you got to make sure that you're adding the humidity in such a way that there's not droplets forming everywhere. They're pretty sophisticated. This is a commercial germination room. It looks like a cooler kind of, but you can see there's some high pressure fog in the air, very, very fine, that just blasts in periodically to keep the room at high humidity. And once these trays germinate, the carts are rolled out and brought into the plug bay and put on the benches. So typically these things are monitored daily, right? So you're looking at anywhere from 12 hours to several weeks, depending on the species. Obviously, for bedding plant production, the early ones are started way in advance. That's all part of your scheduling. And the grower will often remove plugs at just the right time. And often you're looking with a magnifying glass daily or multiple times a day if it's a fast plant to make sure you catch them just as the root is emerging. This is the stage you remove them from the germination chamber. You do not want to have the hypocotyl coming out in the germination chamber. That's not good. We're gonna want to avoid stretch, and that's going to happen real fast. So, got to be on your game. Next is the cotyledons to first true leaf, right? So, uh, this is where root to shoot ratio is important. Now, in a plug, we want good root content relative to shoot. But you have to be careful that it's not overdone so that the entire thing is so root bound, right? But moisture is really critical at this point, and this is where high pressure fog, even in the propagation bench, is the best way to go. A lot of times booms using fine nozzles. Again, we use bottom heat. We've talked about this before to encourage growth of roots. So irrigation is absolutely critical through here. And the other thing that's really critical is preventing hypocotyl stretch. Remember, this is our earliest part that emerges below the cotyledons from the seedling. And using things like red shifted LEDs, like we do at the college, help prevent stretch. So LEDs that have more red, way more red than blue, are used to shift the red-far red ratio in favor of red. Because remember, far red causes stretch. And if we shift the ratio of red to blue heavily to red, we negate the effects of any far red, which helps keep the plugs very short without using growth regulators. The other thing is just using more light, right? You don't have to go crazy and burn them, but higher PPFD will also prevent stretch. Don't be cheap with your lights. Use them. If it's a gray day, put the lights on. Using fogs or booms to keep moisture management uniform. Generally speaking, we avoid plant growth regulators. PGRs are not an option because ultimately we have to grow the thing. And if there's a residual PGR effect, we're in trouble because our crop's not going to be on time. So you do not use PGRs at this stage at all. Generally speaking, most growers use humidity to reduce stretch and prevent lush growth. So this is a real dance to grow them, to control the moisture levels in the root zone such that you don't damage the plant, but nowhere near so wet that you get uncontrolled growth. A lot of times you can start your feed program at this stage as well. So when you have cotyledon expansion. All right, moving on to development of true leaves. Obviously, your cotyledons emerge, and then eventually your true leaf forms. You can tell it's different morphologically. By now, you should know this stuff. I don't have to repeat it. But this is where we control what the plant's going to look like when it starts moving into the reproductive phase. So we got to control branching and growth so we don't have a weak, spindly plant. We often grow cooler here. We might have larger temperature differences between day and night. Growth regulators may start to be applied depending on how vigorous the species is. And of course, diff or morning drops are employed to control height and encourage branching. Yeah, some plants will actually flower early. These are 288 plugs. They're actually fairly small. And you can see they're already flowering. Some plants are like that. Some plants need photoperiod control. We'll talk a little bit about that later. But in terms of controlling growth of leaves, our key things are things like nutrition. Making sure the plants have enough, but not too much. That sounds so easy to say. We'll get into it a bit more further down, so I don't want to talk about it just all right now. The last stage is if you're growing plugs and you're not ready to move them. It's inevitable that happens. So you haven't finished selling out the other bay. You're not ready to transplant your plugs. So you got to hold them. You have to park them. That's a tricky thing to do, right? So you got to lower the temperatures and moisture levels. Try to slow the growth down as much as you can. The other thing is, if you are going to be ready for transplanting, you have to harden the plugs off because there's a big shock going from the prop bench to a pot that's out in the growing part of the greenhouse, the main range. We call that hardening off. So you can do that by holding nutrients back and water prior to transplant. You can use it by dropping temperature, a lot of different things. But unlike some crops, like remember Gerberas, our lesson on Gerberas, some of them you just can't hold back. It's just too risky. So you have to transplant them and at the expense of something else. So otherwise there's going to be permanent damage. And you may even throw the plugs out and start again. That's a tricky one. So transplanting on time, very important. And often transplanting late can be especially a problem. Now here we have plugs that are rooted moderately. This is rooted moderately. This is rooted very heavily, and this one is rooted very heavily. When they're this rooted, when you transplant that into a bigger pot, the outer roots can branch out into the soil, right? That's no problem. They're going to branch laterally and they're going to merge into the soil. They're going to grow out. But the inside of this, the roots often get trapped and they actually get stuck going around and around until they finally find a way out. And so if it's over-rooted, you actually have a reduced response time when you transplant. So you've got to be mindful of that. In the old days, we don't have, for the, doing tens of thousands, you can't do this, but you would slice or rip this root open before you transplanted it so that the roots have an exit point so they can fill the pot quicker. So over-rooting your plugs is not a good thing. I just love looking at prop base. They're just so immaculate. It looks like a golf turf. Anyways, just gorgeous. Beautiful seedlings there. Watering is critical. Growing on time, but growing on the driest side as you can tolerate. And of course, keeping nitrogen feeds to a minimum to prevent excess growth. This is the dance, To put it in perspective, this grower here is probably only responsible for this bay, right? Where a grower over here might be responsible for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bays. But they're both equally as important, but because there's so much involved with growing plugs, this one grower has just this one bay. And there's a lot at stake. Remember, there's probably millions of plants here versus over here. Well, not millions, let's say hundreds of thousands. So they both are taking care of the same number of plants, but just very different context. So it's a really it's a responsible, it's a job that requires a lot of commitment. Often more senior growers are in charge of the propagation area. But anyways, a lot of plants as they're held here will begin to set buds, which is great if you're trying to program so that you can transplant into the next bay and get things done real quick. Let's talk about cuttings. We've talked a lot about seedlings. So vegetative propagation from cuttings is still done for some varieties. Obviously, I got geraniums as an example here. There's a few others that are done like that. But typically, it's only done whenever hybrid seeds are not an option, when they're not available. All right, so remember that for your quiz. But ideally, that's essentially something you should remember. Another thing is that, and this might apply if you're taking cuttings at home, is commercially, again, remember, we're looking for uniformity, okay? So generally, you never take anything other than a tip. So here I've got a geranium cutting that's been taken, and here is the tip, and this is an internode cutting. So you might see 2 or 3 internode cuttings below the tip, and the temptation would be to root them all. But the difference is, this has an apical meristem all ready to go, where these have to initiate a lateral and then grow, which means there's a delay. And a delay means not uniform. So they're only stem or tip cuttings that are taken commercially, okay? That's an important concept. It is much more expensive than seed propagation. So if you're running bedding plants from cuttings, it's going to cost you, I would say anywhere from 2 to 10 times the cost. That's a lot. And then there's the cost of uniformity and all that other stuff. So typically there's more labor at transplanting. I mean, there's a robot. I've got a link to a robot that does cuttings, but it's still often done by hand. So you don't have the benefits of a machine like with seeds. You've got lots of people sitting there sticking cuttings. So you're looking at a lot more money, labor in terms of, buying the cuttings, sticking the cuttings, growing the cuttings, the cost of non-uniformity in terms of planning and being able to capitalize on space. There's just a lot of negatives towards growing from cuttings. Cuttings also provide an opportunity for diseases to enter your greenhouse because here the bag opens and right away whatever environment these came from has now entered your greenhouse, whether it's a bug or a spore or a virus. Anytime you bring cuttings into a greenhouse, it's exciting and terrifying. Typically we choose suppliers to buy our cuttings from based on other people's recommendations, and also whether they do something called culture indexing, which means they screen their plants regularly for viruses and fungal infections. That's really important. So staff should be trained to monitor the cuttings they're sticking, not just stick them blindly. And if they see something wrong, they have to notify the grower right away to catch things, or things go south real fast. It becomes south, sorry. Mental anguish there. Cuttings, I don't want to spend much time on this. We've talked a lot about this, whether it's Oasis or Jiffy or what are these called? Elapots. These are kind of the latest craze, but there's other ones. Rubberized peat called quick plugs are becoming popular, but again, we've talked a lot about that, so I'm not going to get into that. Now, as far as cuttings go, there is something called breeder's rights, and you should know about that. You can't just maintain stock plants and take cuttings willy-nilly if those stock plants are something that has a royalty, because the breeder inspectors will go to stores and look at what's being sold and see who grew it. And if you're selling a plant that normally you should have paid a fee for, they're going to come after you. And they may not just go after you for the fee, they may go after you for damages. So it's important you respect breeders' rights, and that's law that is respected internationally. So be careful with that. So as far as cuttings go, going back to our plugs, let's say our plugs are ready, right? So here you got some impatiens plugs, there's a close-up. They're ready for transplant. If you look out here, these little white specks are actually buds that are just ready to flower. That's perfect time to transplant impatiens. Um, just starting to show those buds. So when it's time to transplant, we go to our robotic transplanter. And again, here's this YouTube is live. If you go to the PowerPoint slides, you can watch it, see how it works. I recommend you do that so you understand what I'm talking about in terms of uniformity. Then, of course, once you have the plugs transplanted, they pretty much grow themselves. Your job is just to maintain balance. Boom irrigation is still highly recommended for uniformity. But at the end of the day, this is where PGRs and water management are critical. Things we can control as a grower. We can control the timing of flowering to some extent, maybe with photoperiod or with how we feed it, nitrogen form, ammonium versus nitrate. We can control the balance of generative versus vegetative. Again, that's related to things like day-night temperature, type of nitrogen, how often we water the soil. Is it really dry soil or really wet? We can also control the branching habit with things like light levels or even growth regulators. And we can control the size of the plant, which is kind of related to this. But I need a drink, sorry. All right. So typically we're looking at, is this able to be mechanized at all, right? Can we use any kind of equipment to save time and labor? And in the bedding plant industry, where margins are very small, automation is king. So sometimes we can control that, sometimes we can't. What are the tools we have? I've mentioned this already many times in the lesson, so repetition is good, right? Water, temperature, relative humidity, quantity of light, duration of nighttime, right? Are we using night interruption or not? Nutrition, is it nitrogen or ammonium? Or is it nitrate or ammonium? And of course, growth regulators. So vegetative growth, this is very much like our tomato lesson in the vegetables course, right? Looking at balancing vegetative versus reproductive. It's exactly the same philosophy. So for vegetative growth, we're using high average temperature with low light. That's a key one there. So you're not going to run supplemental lighting. You're going to have warmer temperatures with lower light. But of course, the risk is that you overdo it in the size of the plant, right? You have to be very careful. Positive diff. What does that mean? Warm mornings, cool evenings. Low VPD. So that means high humidity. So high humidity encourages vegetative growth. High moisture content in the soil. So high substrate moisture. So that means irrigating more frequently, not getting down to the ones and zeros in your moisture scale. And of course, lots of nitrogen and phosphorus. All these things represent massive stretch and growth. So do this with caution. As far as generative growth, or flowers, we can emphasize them by withholding water, right? You tease the plant with a bit of stress and suddenly it's like, whoa, I'm in trouble. It's going to turn flowers on. And it's going to try to reproduce before it dies. High light levels with cool temperatures. So grow lights on, slightly lower temperature if you're trying to steer to lots of generative growth, which means lots of bud set. Abundance of potassium and calcium relative to nitrogen and phosphorus. So, and then of course, if you're worried about stretch, mild phosphorus deprivation. In fact, it also encourages flower to some extent, but I would be very careful with this one. I'm not a big fan of playing around with that. I keep the phosphorus pretty much the same level. Negative diff. So as opposed to positive diff with vegetative, with generative we go negative diff. So cool mornings, warm evenings. So in terms of balancing a plant between generative and vegetative, here we have a petunia that is very well proportioned for shipping. In fact, you would say artificially contained. You got lots of flowers and you have dense, compact leaves. But this is done on purpose because these hanging baskets have to be taken down, put into a sleeve, and put on a cart that fits on a shelf. Now, the one on this side, on the right, is grown out of control. Lots of leaves, very few flowers. That's not going to fit in a sleeve. By the time you put a sleeve on it, first of all, it's going to take ages to get everything in there. The vines will be hanging out the sides, and then you put it on a shelf, and the branches all get crushed or broken off. So, really important to grow your crop accordingly. In terms of inducing flowers, right? With seeds, we have to make sure we don't skip the juvenile stage. We can't force flowers until we finish the juvenile stage. That's the big difference between cuttings and seeds, right? In terms of your speed to crop. The juvenile stage is where you start to have flower induction. So you've finished your cotyledon, you got your true leaves, your apical meristem, and now you're ready to start initiating flowers. Important that you have to understand you got to go through that. The flower induction stage of bedding plants is actually a more recent thing. We used to take a lot of it for granted. There's a ton of research coming in now looking at things like photoperiod and how to control flowering. And we're finding that there are bedding plants that are obligate long day, facultative long day, obligate short day, facultative short day. Those things are really becoming interesting in terms of bedding plant production and worth paying attention to. Looking at your DLI, your daily light integral, making sure that they're sufficient, because remember that sugar, that carbon to nitrogen ratio, we need to have enough light to build up the sugar levels in the plant so that it can sustain flower development. If we want lots of flowers forming at once, we need a good base of sugars. So we got to make sure we have enough light during the day. Then, of course, some plants they're thermomorphic. They like a change in day and night temperatures to trigger flowering too, right? And then, of course, there's water stress, but be careful. You can damage roots and have fungal problems. So. Lastly, hardening off. So you're getting ready to ship your crop. This is where you want to monitor your water levels so that the plant's roots and everything, your leaves form proper cuticles so that they don't wilt the second they leave the greenhouse, right? Hardening off is critical. Mild water stress is one way. It also helps the plant form a cuticle, like I said. It will also trigger slightly earlier flowering, so be mindful of that. I mean, it's all often part of the last stages of finishing your crop. But at the end of the day, you want to make sure your roots are actively growing and looking for water too. If you're just spoiling the plant all the time, the roots don't form properly. So by monitoring your moisture levels to keep them not excessively wet, you encourage the continued growth of roots, which is important, especially for the success of the plant when it's taken to the garden center and planted in a garden. So typically plants grown under moderate water stress have a longer shelf life at the retail area. That's kind of what I was getting at ultimately. So mild water deprivation hardens the plants off so that they get to the garden center and they don't wilt immediately. So what I'm trying to say here is that water control is important, but it needs to be supported with plant nutrition, right? I mentioned earlier that your ammonium versus your nitrate levels impact how a plant shifts, right? Remember, ammonium encourages rapid vegetative growth, and nitrate encourages harder, more compact growth. So at the end of the day, if you're looking at what's called plug feeds or bedding plant feeds, they almost always have very low ammonium levels, and the grower reserves the ammonium for cases of emergency where they need to quickly speed up or enhance the size of a crop. Maybe they made a mistake with a growth regulator calculation or something like that. And again, the ratio of nitrogen and phosphorus and potassium to calcium, magnesium is critical also. And I've mentioned before, it's not so much that we elevate the potassium levels, but we reduce nitrogen and phosphorus somewhat, mostly nitrogen. So instead of it being 30, 15, 30, we have 15, 15, 30. So just remember that, right? So that leaves potassium higher. It doesn't mean that it's required for flowering. It means that we don't want as much of this for flowering. Temperature and climate. So there are definitely some variations in the different groups of bedding plants. For example, New Guineas do not tolerate cold temperatures and they do not like negative diffs. Whereas some plants prefer high average temperatures and respond really well to negative diffs like geraniums and petunias. And then there's some bedding plants that prefer cool temperatures, not warm temperatures, and also respond well to negative diff. Things like wave petunias, which is different from these other ones, interestingly, and dianthus, right? Like your carnation kind of thing. Plants who do not tolerate warm temperatures and do not require a negative diff, for example, things like snapdragons and pansies. So obviously these things are all over the map, and I'm never going to ask you which species prefers what conditions. That's something you look up. Things that have broad generic tolerances, marigolds, dead easy bedding plant to grow, and still, I think, pretty and useful, right? Great around your garden. They encourage beneficials, discourage insects, rabbits even, I'm told. Doesn't work in my garden, but I think the rabbits around our house are pretty bold. We tried lettuce the last couple of years, and honestly, we just fed the rabbits. I don't want to get into this too much, but temperature does do some interesting things. This is looking at flower quantity and quality versus temperature. And what's interesting is that zonal geraniums seem to deteriorate in quality the warmer you grow them. So interesting to note, right? Warmer is not always better. Then looking at some photoperiodic things with bedding plants. This is looking at obligate long day plants. So these are plants that require long day. So if you go down the list, see if you recognize any. Aster, flax, gazania, lavitera, lobelia, primrose, straw flowers, tuberous begonias. Anyways, down the list you go. Plants that are facultative, which means it helps, but they don't require long days. Basil, interesting, it's an herb. Snapdragons, sunflowers, ageratum, wonder if you know what that is, calendula, dianthus, little carnations. Anyways, then there's obligate short day, so plants that require short days, so long nights. African marigold, interestingly. Not generic marigolds, this is an unusual variety. Hyacinth, not that you grow these very often in our culture for bedding plants. Facultative short day, celosia, that's one you see. Coneflower. Cosmos, that's these guys. Zinnias, moonflowers. Anyways, morning glory. Day neutral, bunch of them. Amaranthus, cleome, geranium. Well, anyways, you get the idea. This is looking at Cosmos. This is a paper that was done a few years ago. The number of short days and how it impacted flowering. And if they didn't have enough short days, they didn't get flowering. And so you can kind of see that the best quality seemed to be achieved from 20 on for short days. So people who grow Cosmos, that's what they do. In terms of supplemental lighting, so adding grow lights you get more vegetative growth, but the biggest difference that was noted was root growth. So that's important for establishing a good plug, right? We have to make sure it's not overgrown, but we want the roots to fill up that plug as quickly as possible so that when you pull the plug, all the soil comes with it. And that way you know you've got it rooted sufficiently. So yeah, definitely light intensity had a big difference. So the top is the control, by the way. Bottom one is HPS. So fair difference. As far as supplemental lighting for plugs, your DLI, typically around 12 moles, PPFD is sufficient. Anything over the minimum will increase the number of flowers and branches, which is a good thing. So this is the bare minimum for amount of light that you need, which is not a ton, honestly. But obviously enough light is going to keep the plants compact. That's important. And it's going to shorten your crop time, which is important for making money, right? Growth regulators, I'm not going to get into it, but I want to explain that, if you don't use growth regulators, let's say you use water, climate, and nutrition, you can quickly reverse those if you need to speed up a crop. Whereas if you spray a crop with something like bonsai, you're done. You can't reverse it. It's got 3 to 6 weeks of control. So you either have the right size or you don't. And this is a really good example of fuchsia that they got it wrong. Like that's not saleable. That's going to go in the bin. Anyways, bedding plants, flats, lots of stuff. I have a bunch of slides here I wanted to go through because I know you do plant ID, but I find that my students are still not familiar with the basic bedding plants. So what are we looking at here? Begonias, but we're looking at wax or fibrous begonias, which is a big difference from, what are these? Tuberous begonias. Notice the size of the flowers. Look at the leaves. These are shaped like an ear with a point, where the waxy ones don't have the veins and they're smaller. Both begonias, but very different. What is this? Yeah, you knew that. Petunia. What are these? Ooh. Calibrachoa, sometimes called million bells. These are very, very popular. Prolific bloomers. Almost more popular than petunias, although petunias have experienced a bit of a comeback because they're very drought tolerant. What is this? Impatiens. Also related to this, jewelweed, which you see growing on the sides of trails in the Bruce Trail. Did you know, little fun fact, if you get poison ivy, if you take the jewelweed stem and leaves and crush them and rub that into your poison ivy, it will alleviate the itch and the oozing. That's a indigenous cure for poison ivy. Anyways, we're looking at impatiens. What are we looking at here? Wait a minute. They look like impatiens. In fact, this is what the last slide was, but these have pointy leaves with kind of rough veins. What's the difference? These have more rounded leaves with less visible veins. These are called sun impatiens or New Guineas. So impatiens hawkeri, whereas the regular impatiens are called impatiens walleriana, whatever. Anyways, what is this? This is sometimes called coxcomb, paintbrush, celosia. Personally, not a big fan of these things, but hey, some people really like them. What is this? Now we're digging, and you're scratching your head. You're saying it's a bunch of hungry dinosaurs. Nope. Keep guessing. Torrenia. You better know it because it's becoming popular. What is this? Another one that's very popular, primarily because it is something that attracts butterflies. And it's also beautiful. Comes with all kinds of different coloring flower arrangements. Just a beautiful plant. I love them. They grow really well. Do you know what it is? Lantana. This is another interesting bedding plant that is very popular. Technically, it's not actually grown for the flowers. The flowers aren't very showy. It's grown for the leaves, and the foliage comes in all kinds of variegated conditions. This is known as coleus. Very easy to propagate by yourself, by the way, but again, no one does. Ooh, what is this? If you're into astronomy, Osteospermum? Never mind. Maybe not many of you are astronomers. Osteospermum is otherwise known as osteos. These are grown in hanging baskets and planters a lot of the time, very showy. These are tricky to grow. They look like a daisy. They're not really a daisy, but what is this? Very easy to grow from seed. Self-seed in your garden. Sweet pea. And of course, you know what this is? It's a geranium. And then what is this? Is it also a geranium? Not necessarily. These are called ivy geraniums. These are trailing. Usually these are in hanging baskets or planters. They hang down as opposed to the previous slide where they're sort of upright in a potted container like a standard. Ivy geraniums are very popular in Europe, less so in North America. I don't know why, because I think they're beautiful. We do grow some at the college every year, and hopefully we see them this year. So it's an ivy geranium, and it's a trailing one. What is this? It's another kind of geranium. Anyone know? It is Martha Washington geranium. Personally, don't care for them for the headache and the cost. Some people really like them, but no. This one. These reseed in your garden and can be stuck with you for life. So think long before you plant them. Snapdragons. Very, very tough plants. This is an interesting one. Grown from seed, they form beautiful full ball hanging baskets. And the second you forget to water them, they die instantly and there's no recovering. It is, let me guess, lobelia. Not to be confused with this one, which if you look at it, turn this upside down, looks like a Japanese fan that you would, wave at your face to cool. So that helps you to remember because it is a fan flower, otherwise known as scaevola. This is your classic rudbeckia, much like a daisy. I love the dwarf varieties of these. They're very showy, they're tough, and they're beautiful, and they flower all summer. I think they're great. They're also excellent for attracting pollinators. Really good, and they come in a variety of different colors. I don't know why I'm talking like this, because I love flowers and they look great. This is another astronomy one. Carl Sagan named these. No, I made that up, but they are called cosmos. And again, they attract pollinators, and they're beautiful, and they're tough. Yeah. This is another one I like that's not as popular. They're drought tolerant. They flower all summer. They're low to the ground. They're mounding. They are called, and they have a cool name, portulaca. If you look, they have a succulent leaf, which tells you that they're drought tolerant. They can be a needle, or they can like an oblong or an ovate leaf. Then there is, what is this? Grows with a rhizome or a tuber. I think that's actually a tuber. What are they? Dahlias, yeah, tuber. Actually, dahlias are something that I'm not a fan of because they're expensive and they rarely look as good as this. But that's just in my opinion. And this is a beautiful one I love. They grow cool commercially, so you save money. Gorgeous flowers, but you got to be really careful with overhead watering because with that convoluted flower, water gets stuck and you get botrytis. Does anyone know what these are called? Ranunculus. See, I'm picking some trickier ones. Bet you didn't know all these.